1.5 applications of the quadratic equations. So we are going to solve for two different types of the application question. One is a geometric problem, another one is a falling body problem. The length of a rectangle exceeds its width by 3 feet. If its area is 40 square feet, now we need to find its dimensions. So that means we need to find the length and the width. The rectangle shape here, it gives us the information is the length exceeds its width. That means the length has 3 feet longer than its width. So we set the length is equal W plus D, and the width is equal W. And it also gives us the area is 40. So the area of a rectangle would be the length multiplied with the width. Now, we have set up length is equal to W plus D. So I'm going to substitute the length with W plus D, multiply with the width. So this width, right? And the area has 40. Now distribute the right hand side. Let me put to the left side. I have the W squared plus 3W equal 40. So I bring the 40 to the left hand side, turn to the 0. Now we have trinomial quadratic equation. First thing, we want to go with the factoring. Leading coefficient just 1, so I have the W multiply with the W, will go back to the W squared. Two number multiply, you'll get a 40, would be A by 5. The middle term is a positive 3. That means the bigger number has a positive sign, small number has a negative sign. Now, up here, we have the zero factor form. From the zero factor form, we can solve for unknown variable by using the zero factor theorem. So we set the W plus A equals 0, which is W equals negative A. W minus 5 equals 0. So we get the W is equal 5. So we have two solutions. However, this solution is a geometric problem. When we have a geometric problem, we don't take the negative solution because it doesn't make sense. So we only have one solution, is the width is 5. So since we know the width is 5, that means the length is 5 plus 3, which is 8. So this will be the dimension of the question. And this is feet and feet. I hope that makes sense too. Now we take a look at another example. If a water balloon launcher propels a water balloon straight up into the air with an initial velocity of 144 feet per second, its height is given by the formula. This is a formula where h represents the height in feet, t represents the time in seconds since it was launched. How long will it take for the water balloon to return to the point from which it was launched? So now add the equation of this formula into this form. So we'll have that h is equal to negative 16 t squared plus 144 t. So now we need to find how long it will take the balloon return back to the initial position, right? Where it was launched. So this is initial position, And when the balloon release, how long it will take the balloon back to the same position. So that means the distance between these two locations is 0. The height is 0. So we let the height is equal 0. Now the right hand side, we only have two terms. So we take out the common factor of negative 16t. And then you have t minus, because the common factor is a negative term. So your second term will change to minus 9. Now from here, you have the factor form. Now we let the factor form turn to the 0. T minus 9 is equal to 0. So your t is 0, or t is equal to 9. So if I interpret the solution of these two, that means when the balloon is still holding the hand, there's no time, right? There's no time differences. The balloon still stays in the same location. Or after 9 seconds, when the balloon go to the air, take 9 seconds, it will go back to the same position from where it was lodged. So this is question example 2 on your 1.5. You can work on web